This Canadian admiral has seen better days. Some fool forgot to check to see if there were batteries in it when he picked it up at a garage sale about 16 years ago. Then stuck it in storage. And then about a year ago, I pulled it out of storage and found the schematics for it, which I'll include a bit later. And unfortunately, that website is no longer in existence, which is a shame. But the batteries, of course, leaked. I'm not going to blame Duracell for this one. The batteries are somewhere between 16 to 20 years old, maybe longer. The Ever-Ready is slightly bulged, but it does not appear to have leaked. I'll be taking these to the sink to remove them. Then I'll bring it back and start cleaning it. But what's a shame is that this was probably made in Canada. Canadian Admiral had production facilities in Mississauga, Ontario, Cambridge, Ontario, and Montgomery, I think it is, Quebec. But they all closed down in 1981 when interest rates went through the roof. But in the States, they were produced down in Clarksville, Tennessee, under a different name, of course, by Barnett Instrument for the U.S. military. So the ones for Canada, produced in Canada. Now, this one actually, the display here is from Stark Electronic Instrument Limited, Ajax, Canada. Ajax in Ontario is on the east side of Toronto, and Mississauga, though is probably Port Credit at the time, is on the west side of Toronto. So, hey, this might have come right out of southern Ontario. So, I'll show you the schematics I got in a moment, but I'm going to take this to the sink and clean out those batteries. And here's the manual I found for it. U.S. military version, but it is identical. Pretty simple design. You can just freeze frame it if there's something you want to look at. One of the key parts, though, is going to turn out is the ohm adjust pot. You'll see it in a moment how messy it is. Okay, batteries are out. I'm going to just do some toothbrushing to clean off some of this. I'm probably going to have to do some disassembly because there's heavy amount of corrosion on one part in there. So I'm not going to show you all of this. I'll show you the next step when I've got it further in. So I'm a bit further in now. Now I'm just going to be doing a lot of brushing and slowly picking away, and I really hope this is salvageable in here. But I'm... Okay, ohms. Oh, it does rotate. So, we shall see. And just to show you a bit of the fizzing, that nice little acid attacking the base. And continue. Okay, so after cleaning it with vinegar, I used a bit of isopropanol to help flush off the residue vinegar. I've been able to clean this up quite a bit. There doesn't seem to be any apparent damage unless there's damage inside here. I'm going to have to just let this thing sit and dry now. One thing I did notice on the isopropanol is this lettering was fine because it looks like it's been clear coated over, but it probably had a calibration date in here, and sadly some of that rubbed off. But the rest of it's looking pretty good in there. it was most of the damage was up in here, and this thing looks like it was clear coated enough to put up with almost anything. So I'm going to pause, let this dry, and then get back to it. And not good. The ohm adjust is clearly shot. I've disconnected the one lead here, and this should be reading between 0 and 20K. So there must be heavy corrosion inside. Now, this should not affect the DC volt part of the meter, so I'm going to take a look at it next. So, with no voltage, DC voltage attached, on the 1000 volt scale, you can see it's off the 0 a tiny bit. There's 100, 10, and 1. So there's just a tiny bit of an offset on it. Not too bad. Okay, I'm going to hook up my bench supply. Bench supply right now is set at 22.36. That's not too bad. Now let's adjust the voltage down. To 16 volts. Oh, that's pretty well bang on. Take it down to 8 volts. And not too bad. Switch it over to the 10 scale. Pegs. So obviously something on that part of the circuit's off a tiny bit. I'm just going to take a look at the schematic. Okay, if you take a look at the schematic that I've included somewhere in this video, this is pretty idiot proof. So it's most likely the contact in here is off a tiny bit, or a bit garbagey. I'm going to now take the voltage down to 0.5 of a volt. Not bad. It's closer. And what happens when we switch to this? I'm on 0.49 of a volt. This is reading a bit high, so it's just probably a bit of garbage on the contacts. I'm just going to disconnect this for a moment. Old-fashioned, take it back and forth as many times as you want. And let's see if the reading actually changes. Not appreciably. I'd have to get in there and clean the contacts. But question is it worth spending the money to fix this up, or just keep it as something that looks cute? And I think I'm going to just keep it as something that looks cute, because those 22.5 volt batteries are not exactly cheap. And I might change the pot out eventually, this one here, since it's a 20K pot, but it's a pretty long shaft in there, so this thing would probably be a pain to find, and I got meters that are a lot more accurate. So not totally salvaged, but it's cute to look at. So I'll reassemble it now with a little note to make sure that if I do ever come back to this one, I'll know that I better pull out that pot. So it's all reassembled, minus batteries, and it can get put back in this little case here. There you go. And I'll give you the weight of how much this thing weighs. And back into storage. Have a good day, and I'll try to cut a bit of this stuff out to make it a bit quicker.